Hello friends. Today we will talk about how innovative energy solutions can work towards a sustainable and clean environment. All energy sources have some impact on our environment. Fossil fuels, coal, oil and natural gas do substantially more harm than renewable energy sources by most measures, including air and water pollution, damage to public health, wildlife and habitat loss, water use, land use, and global warming emissions. The exact type and intensity of environmental impacts varies depending on the specific technology used, the geographic location, and a number of other factors. By understanding the current and potential environmental issues associated with each renewable energy source, we can take steps to effectively avoid or minimize these impacts as they become a larger portion of our electric supply. All forms of electricity generation have an environmental impact on our air, water, and land, but it varies. Producing and using electricity more efficiently reduces both the amount of fuel needed to generate electricity and the amount of greenhouse gases and other air pollution emitted as a result. Electricity from renewable energy resources such as solar, geothermal and wind generally does not contribute to climate change or local air pollution since no fuels are combusted. So, the question arises, what are the causes and what are the most immediate cost-effective strategies? But the challenge is more fundamental than the idea of mitigation, as important as they might sound. Hence, we have to rethink and change our 2 centuries-old fossil fuel economy to renewable resources. A more fundamental question is, can we do it in time to avoid disasters and human hardships? India's energy consumption is set to grow 4.2% a year by 2035, faster than that of all major economies in the world. Solutions for tomorrow for sustainable development goals are being invented in India. And India has an incredible capacity to think differently, and this is solving energy-related problems in our country. To begin with, we have biomass energy. Traditional biomass, primarily for cooking and heating, represents about 13% and is growing slowly or even declining in some regions as biomass is used more efficiently or replaced by more modern energy forms. Some of the recent predictions suggest that biomass energy is likely to make up 1/3 of the total world energy mix by 2050. In fact, biofuel provides around 3% of the world's fuel for transportation. We have discovered that food waste, the sludge from primary sewage treatment, and green waste from the landscape, urban gardening, and agriculture together generate a significant energy resource in the form of biomass. With serious concern globally and in India on the use of fossil fuels, it is important for India to start using renewable energy sources. India is the 7th largest country in the world, spanning 328 million hectares and bestowed with renewable sources of energy. Among the renewable energy sources, biomass plays a vital role, especially in rural areas, as it constitutes the major energy source to majority of households in India. Biomass energy is the utilization of organic matter wherever present and can be utilized for various applications. India produces about 450 to 500 million tons of biomass per year. Biomass provides 32% of all the primary energy used in country at present. New technological breakthroughs in biogas generation use a 2-stage anaerobic process to convert as much as 80% of the potential energy in the biomass into biogas, which is methane and hydrogen gas. This energy source can be put to many uses, for example, providing gas for cooking, compressed gas for gas-powered vehicles, or powering gas electric turbines for the base or backup electric loads. Biodiesel is not being sold extensively in Indian fuel market, but the government plans to meet 20% of the country's diesel requirements by 2020 using biodiesel. Plants like Jatropha Neem, mahua, and other wild plants are identified as the potential sources for biodiesel production in India. There are about 63 million hectares wasteland in the country, out of which about 40 million hectares area can be developed by undertaking plantations of Jatropha. India uses several incentive schemes to induce villagers to rehabilitate wastelands through the cultivation of Jatropha. Biomass can play a major role in reducing the reliance on fossil fuels by making use of thermochemical conversion technologies. In addition, the increased utilization of biomass-based fuels will be instrumental in safeguarding the environment and generation of new job opportunities, sustainable development, and of course, health improvements in the rural areas. The development of efficient biomass handling technology, improvement of agroforestry systems, and establishment of small and large-scale biomass-based power plants can play a major role in rural development. Biomass energy could also aid in modernizing the agriculture economy. Next, we have the solar energy. It creates clean, renewable power from the sun and benefits the environment. Alternatives to fossil fuels reduce carbon footprint at home and abroad, reducing greenhouse gases around the globe. Solar is known to have a favorable impact on the environment. India receives solar energy equivalent to over 5,000 trillion kilowatt-hour per year, with about 300 clear sunny days in a year, generating electricity with solar power instead of fossil fuels, which can dramatically reduce greenhouse gas emissions, particularly carbon dioxide. Greenhouse gases, which are produced when fossil fuels are burnt, results in rising global temperatures and climate change. Climate change already has contributed to serious environmental and public health issues around the world, including extreme weather events, rising sea levels, and ecosystem changes. In 2011, the International Energy Agency said that the development of affordable, inexhaustible, and clean solar energy technologies will have huge long-term benefits. It will increase countries' energy security through reliance on an indigenous, inexhaustible, and mostly imported independent resource, enhanced sustainability, reduce pollution, lower the costs of mitigating global warming, and keep the fossil fuel prices lower than otherwise. These advantages are very much global. Hence, the additional costs of the incentives for early deployment should always be considered learning investments. They must be wisely spent and need to be widely shared. Due to advancements in science and technology, today solar energy is being used in various sectors ranging from commercial to industrial purpose. Solar heating, solar chimney, solar air conditioning, furnace, solar ponds, water disinfection, solar desalinization, solar electricity, passive solar building design, and urban heat island. Even in the field of agriculture and horticulture, solar energy can help optimize the productivity of plants. Even the transportation sector has contributed a lot by investing in the field of solar power. Solar vehicles have already begun to make its mark on the roads. Toyota, Tesla, Mahindra & Mahindra, etc. are giving its way to solar power cars. As far as solar heat for industrial processes is concerned, an estimated 35 gigawatts of new solar thermal capacity was commissioned in 2017, increasing total global capacity 4% to around 472 gigawatts thermal. China has new installations, followed by Turkey, India, Brazil, and the United States. There are also records for new solar heat for industrial processes installations, which are driven by economic competitiveness, a strong supply chain, and policies to reduce air pollution. At least 110 such systems started operational globally, raising the world's total by 21%. Concentrator and collector technologies have played an increasing role in providing space heating and industrial heat, with Oman, China, Italy, India, and Mexico being the largest markets. The International Solar Alliance, which was created at the same time as the Paris Agreement in December 2015, announced by India's Prime Minister Mr. Narendra Modi and France's then President François Hollande. The Paris Agreement, of course, is the historic global climate agreement which came out of the United Nations Conference of Parties 21 climate conference in Paris, France. The ISA opened its door to an ambitious collaboration on climate solutions and gave the world hope that we could reach the goals set forth in Paris Agreement. Over 120 nations, most of them being the sunshine countries near the equator in the torrid zones, are a part of ISA. Many of these countries, despite being solar rich, have higher rates of energy poverty and lack widespread access to modern systems of electricity. According to United Nations, ISA focuses on investment in large-scale solar energy in developing countries to both meet escalating energy demands and fight rapid climate change. The ISA is aiming to mobilize more than $1 trillion in order to triple the amount of solar energy installed around the world, and all before 2030. That's a target of over 1 trillion watts of solar installed across the earth in just the next 12 years. India, on the other hand, is working tremendously on promoting solar equipments in every sector, thereby keeping its target of using the renewable energies online. Few of the solar-based equipments will be discussed now. First, we have solar water pumping systems. A solar photovoltaic water pumping system consists of solar panels, an on-off switch, a control and a tracking mechanism, and a motor pump. The system essentially uses solar photovoltaic cells for converting solar energy into electric current. A solar photovoltaic cell capacity can range around 200 watts to 5 kilowatts peak, based on the needs of different water sources such as bore wells, open wells, reservoirs, streams. A system with 1000 watt power capacity can irrigate about 2 acres of land, pumping approximately 40,000 liters of water per day. A solar pump system with 5 horsepower capacity costs around Rs 4,39,000. Some states in India offer subsidies of up to 80% to farmers for encouraging the use of solar energy. Several manufacturers such as Kirloskar, Schneider Electric, Tata Solar, etc. offer a wide range of solar pumping systems in India. Next is solar dryers. Solar dehydrators or dryers are used in farms to dry crops before sending them to the market. These dryers commonly use passive solar panels for generating energy. A large-scale solar dryer usually consists of shed, drying racks and a solar collector panels. The crops are dried when hot air is circulated through the shed by natural convection or using a fan. Natural convection solar tunnel dryers are another type that can be used for drying bulk material and high moisture content. These dryers have exhaust fans at the upper end of the tunnel to drive away humid air. Adequate insulation is ensured on the floor and upper sides of the dryer to prevent any kind of heat loss. Solar greenhouses. It makes optimum use of solar energy for providing heating and insulations. Specialized solar greenhouses can collect and store energy for nighttime use or during cloudy weather. Solar-powered photovoltaic cells can be used to collect solar energy for additional insulation in colder climates. Another solution is to use water tanks heated by solar power for circulating heat, which maintains the temperature at a level suitable to grow vegetables throughout the year, enabling the vegetables production during off-seasons as well. Such greenhouses using passive solar technology have been built for costs starting at Rs 30,000 in Ladakh. Next, we have solar-powered electric fences. They are highly effective and dependable for large fields and cattle farms. The batteries can be recharged using ready-made solar fence chargers. Battery-operated solar fences may cost from 45,000 to 50,000 rupees per acre. Cheaper versions costing as low as 10,000 to 25,000 rupees per acre have been developed using locally made materials in some places in India. Next, we have solar milking machines. Solar milking machines for cows operated on solar power instead of diesel or electric power are another innovation. Some states like Karnataka provide subsidies of up to 50% for these machines. Nearly 300 million people living in rural India are still using primitive sources of energy like kerosene and wood-fired stoves, which expose them to life-threatening diseases and exacerbate environmental problems. The government declared 2019 as the year for every Indian household to get electricity. Under the Saubhagya scheme, the government has given more emphasis on encouraging distributed solar power. Through the easy deployment of decentralized solar power, the end user is brought closer to the source of the generation, which impacts the rural population directly. Next, we have wind energy. Like solar energy, it is free energy resource, but is much intermittent than solar. Windmills can be set up ranging scales of onshore grid connected wind turbine systems, offshore wind turbine systems, small wind and hybrid energy decentralized systems, which is floating. It is estimated that with the current level of technology, the onshore potential for utilization of wind energy for electricity generation is of the order of 65,000 megawatts. India also is blessed with 7,517 kilometers of coastline, and its territorial waters extend up to 12 nautical miles into the sea. The unexploited resource availability has the potential to sustain the growth of wind energy sector in India in the years to come. India has a target to achieve 60 gigawatts of power from wind by 2022. As of June 2018, the total installed wind power capacity was 34.293 gigawatts, the fourth largest installed wind power capacity in the world after China, US and Germany. Wind power capacity is mainly spread across south, west and north regions. Tamil Nadu has become a leader in wind power in India. In Mupandal wind farm, the total capacity is 1500 megawatts, the largest wind power plant in India. Sweden is aiming to become one of the first countries to generate 100% of its electricity from renewable sources. But it has a wind power capacity of 6.7 gigawatts, a tenth less than Tamil Nadu. Figures from the Global Wind Energy Council show that there are only 5 European nations plus China, the US, Canada and Brazil that has larger installed wind power capacities than Tamil Nadu. According to unofficial data, wind power generation's capacity in the state of Gujarat has increased a staggering 10 times in just 6 years. ONGC Limited has installed a 51 megawatt wind energy farm at Bhuj in Gujarat. India started planning in 2010 to enter into offshore wind power, and a 100 megawatt demonstration plant was located off the Gujarat coast, which began planning in 2014. With more than 25 years of experience in wind farm installations, India is quite competent in most of the supply chain management. However, still there exists scope for imbibing techno-economical interventions from global experiences. Next, we have the geothermal energy. It is the thermal energy generated by the radioactive decay of materials in the Earth's interior. It can be harnessed virtually anywhere on the Earth, but viable methods are possible only at the surface or near surface expressions. And these surface manifestations, like hot springs, have been used by humans since ancient times. The first geothermal pumps were used in the 1940s, and the first geothermal electric plant became operational only in 1960. Many countries since then have been investing in geothermal energy as a clean and renewable energy source, as it is more relevant now than ever. There are two basic types of geothermal heat resources which can be harnessed. The first is hydrothermal heat source, where the heat is transferred by water to the surface. Water is recharged into the ground by rain or surface bodies like river, lakes or glaciers, and it is then heated by underlying hot rock, which is hot due to seismic or volcanic activity. The presence of hot springs in Iceland, the Himalayas and the Alps is an example of this. The second type of resource extraction can be done by deep or enhanced geothermal systems, in which a deep borehole is dug to reach the hot basal rock, and then water is pumped into the holes to obtain the steam. which is aimed to run a turbine. Assessing the deep basal rock bed is an expensive process, and hence this method isn't as popular. In India, exploration and study of geothermal fields started in 1970. The GSI, Geological Survey of India, has identified 350 geothermal energy locations in the country. The most promising of these is in Puga Valley of Ladakh. The estimated potential for geothermal energy in India is about 10,000 megawatts. There are 7 geothermal provinces in India: the Himalayas, Sohana, West Coast, Cambay, Son Narmada Tapi, known as Sonata, Godavari, and Mahanadi. USA, Philippines, Indonesia, Mexico, Italy, and Iceland are leading countries availing commercial exploitation with world production of about 12,000 megawatts. For harnessing geothermal energy in the country, the Ministry of New and Renewable Energy has been supporting research and development on exploration activities and resource assessment during the last 25 years. This includes formation of expert groups, working groups, core groups, and committees, in addition to providing financial support for such projects and for resource assessment. Ministry is also targeting for deployment of geothermal capacity of 1000 megawatt thermal in the initial phase till 2022. Next, we have the hydrogen energy. It is a clean fuel and an energy carrier that can be used for a broad range of applications as a possible substitute to liquid and fossil fuels. The Ministry of New and Renewable Energy has supported research, development, and demonstration projects on various aspects of hydrogen energy, including its production, storage, and use as a fuel for generation of mechanical, thermal, electrical energy. The application of hydrogen in fuel cells for power generation has been demonstrated as a result of initiatives taken by the ministry. Hydrogen-fueled small power generating sets, two-wheeler motorcycles, three-wheelers, and catalytic combustion systems for residential and industrial sectors, and fuel cell buses have also been developed and, of course, demonstrated. Hydrogen is high in energy, yet an engine that burns pure hydrogen produces almost no pollution. NASA has used liquid hydrogen since the 1970s to propel the space shuttle and other rockets into the orbit. Hydrogen fuel cells power the shuttle's electrical systems, producing a clean byproduct, pure water, which the crew drinks. Many initiatives have already been taken in the country, like a hydrogen-fueled three-wheeler developed jointly by IIT Delhi and Mahindra & Mahindra, hydrogen CNG dispensing station which is set at Faridabad in Haryana and Dwarka in New Delhi, vacuum induction melting furnace at Banaras Hindu University, Varanasi, run by hydrogen-fueled energy generator set developed by IIT Delhi, use of hydrogen in a telecom tower for providing backup power as well. The first commercially produced hydrogen-fuel cell automobile, the Hyundai Tucson FCEV, was introduced in 2013. Toyota Mirai followed in 2015, and then Honda entered the market, of course. Fuel cells are also being developed and tested in trucks, buses, boats, motorcycles, and bicycles, among other kinds of vehicles today. With increasing use of hydrogen and technical advances, the cost of production, distribution, and product manufacturing will definitely become increasingly affordable. By continuing to build partnerships between business, government, universities, and non-profit organizations, hydrogen will be the foundation of a sustainable energy economy. Modern-day energy resources are not universally accessible because an inequity that has moral, political, and practical dimension in a world is into the process of globalization and is, of course, connected. The present energy system is not sufficiently reliable or affordable to support global economic growth. The productivity of 1/3 of the world's people is compromised by the lack of access to commercial energy, and perhaps another third would suffer economic hardships and insecurity due to unreliable energy supplies. Local, regional, and global environmental impacts of energy production and its use threaten the health and well-being of our present and future generations. Addressing such issues is a global challenge, and sustainable development is indeed a global goal. And now I would like to conclude with a quote by Sir David Attenborough, which says, "Surely we have a responsibility to leave for future generations a planet that is healthy and habitable by all species." Thank you.